Hi everyone, we're going to do a review for combustion air sizing as per the B149.1 code. We've done it together in class, but we're going to review, go over the basics. Remember, you can pause the video if you want to refer to a code clause, read it so that you know what I'm referring to. All right, so the first thing that we're concerned about is what type of appliance we're talking about. Now, as you know, if you end up having a direct vent, or equivalent to direct vent, so 2 pipe high efficiency, then for those, we're not going to do this combustion air sizing. This is only when we're taking the combustion air sizing from inside of the structure. Okay, so we're not going to be using these with our combustion air sizing. What you're going to be referring to is 8.2.1, but before we get into that, the two types of appliances that we need are you're going to have your conventional appliances, so something that ends up needing dilution air. So whether we're talking about a water heater, anything like that where you have dilution air going up into the draft control device, then we consider that to have a draft control device. So if it has dilution air required, then it has a draft control device. So we need to separate our appliances having draft control devices and not having draft control devices. Okay, so if you have a draft control device, it's going to be treated completely differently than if you do not have a draft control device. So let's clear the board. Great. So now what we're going to do is consider the type of structure. So whether we're talking about a cottage or a house or a shed in the backyard, anything at all, any type of structure, we're concerned about how it's been built. So if it has a vapor barrier or an air barrier, anything basically made out of plastic, so if it has a vapor barrier that's going to be coming down and stopping infiltration and outfiltration, then it's going to be treated completely differently than if we have a structure that is going to be with no vapor barrier, okay? And equivalent to. So we are either going to call this equivalent to tight or equivalent to loose. All right, so let's start off with equivalent to loose. Basically, air is going to come in and out, no problem. But what we need to know is what is the volume of the structure. So again, we're talking about a structure, not an enclosure, and your definitions are in your code book. But basically, our structure is the building, and our enclosure are rooms within the building. So initially, I'm going to look at the building. So let's say that we're talking about a shed in the backyard. So if this is a shed, and then inside of it, we end up having a pool heater. We're going to have our combustion occurring inside of there. Now, if it's nice and loose and we don't have any kind of mechanical exhaust at all, then from there what we're concerned about is, yeah, there's air in there, but is there enough air for it to burn properly and safely? So we consider the volume. So if this was going to be 10 by 10 and then 8 foot high, then we're talking about a volume, not square foot, not area, a volume of 800 cubic feet. So we've got a volume of 800 cubic feet, and then we have the structure, and we want to figure out, is there enough air? So the first thing that we're going to do is say, does this comply with 8.2.1? No, it does not comply with 8.2.1. If you read 8.2.1, then you end up saying that it's going to be a structure that has a vapor barrier for A, 8.2.1A, but the 8.21B is referring to equivalence. So that's when we're talking about our depressurization tests and how much of a negative is happening inside of here. So this has no mechanical exhaust, no vapor barrier. So no and no vapor barrier. So it does not comply with 8.2.1. So yes, over here with the vapor barrier, no over here with no vapor barrier. So because of that, we now have to consider, does this appliance have draft control device? So if it has a draft hood, so let's say that it does have a draft hood. So if we have dilution air going inside of there, then it has draft control device. At the top of your charts, it's going to specify if it has a draft control device or not. And so if you read at the top of 8.3, so this is table 8.3, it's not a clause, table 8.3, then it says this is for structures that do not comply with 8.2.1. and for appliances having draft control devices. So if it has a draft control device and it does not comply with 8.2.1, then we're going to table 8.3. So I'm going to check my 800 cubic feet, and then my input in this case, let's say that it is 250,000 BTUs. 1, 2, 3. So 250,000 BTUs, and we're going to check our code now, and then we'll clear the board. We'll come back and figure out what we need. So let's clear the board. Okay, so I just looked at table 8.3, and using what we just talked about, where we had 800 cubic feet of volume, and then our appliance had a draft control device. And our input was 250,000 BTUs. So when I look down at that chart, it's got 36 written down. And so 36 means that we need to have equivalent to 36 square inches of free area opening. So no grill, nothing blocking it. We've got 36 square inches of free area opening. So that is how much air will need to be brought in from outdoors into that shed to allow that appliance to burn safely. Okay, so we have to put a hole in the wall and we have to direct that air into that space so that we can allow it. So even though it was super loose, super loose, even though we didn't have any vapor barrier, we had no mechanical exhaust, none of that stuff, it doesn't have enough air. So we have to put a hole in the wall and allow the air to come in from outdoors into the structure. Okay, so that's what we figured out there. I'm going to move on to what if it gave us a 0. So let's give an example of it's a cottage. And if it's a cottage and we ended up saying, okay, as far as cubic feet, we've got, let's say 8,000 cubic feet. And then I've got a couple of appliances in there, and both of them have draft control devices. So I'm still sticking to 8.3. It's still at 8.3. There's no vapor barrier, there's no mechanical exhaust. So at this point, if I said, okay, I've got 50,000 BTUs from one appliance, and I've got 100,000 BTUs from the other appliance. So I have a combined input of 150,000 BTUs. Combined input of 150,000 BTUs. And I would say that my cubic feet, my volume, is 8,000 cubic feet. So at that point, I go down to my chart and I find out, oh, with that I end up having 0. So my chart tells me that I need 0, and 0 is wonderful. 0 means that there's enough air inside of the structure for complete combustion to occur. So if I look at that, if I take a look at the chart, it gives me a 0. So that's wonderful. Now what could change? What could change is that inside of this building, we have an enclosure. So yeah, the building has lots and lots and lots of air, but this enclosure doesn't have the same amount of air as the building. So we have to allow for communication in between the enclosure and the structure. We're allowing for communication in between the enclosure and the structure. So from that, I now have to refer to 8.2.6. And 8.2.6a says that all appliances having draft control or not having draft control, all appliances need to have a lower opening that's going to be 1 square inch per 1,000 BTUs. So if I take a look at what I have here, I've got 150,000 BTUs. I divide that by 1,000. and that means that I have 150 square inches required. So I have to have 150 square inches of an opening in the lower portion. But then I keep reading what 8.2.6 says, and B says that if the appliances have draft control devices, and they do, they have draft control devices, if the appliances have draft control devices, then I need a second opening that's the exact same size. And that's because initially we had our 15:1 ratio that you know that we need for complete combustion when we include excess air. So it starts off 10:1, you already know that. It goes up to 15:1, and then as soon as we have dilution air requirements, it becomes 30:1, so they've doubled it. So the lower opening, 150 square inches. The upper opening is also going to be 150 square inches. Okay, so initially we're using tables 8.3, and then where there's no draft control devices, so if we have a venter, we have any type of appliance that does not require dilution air, then at that point we would go to 8.4. We consider the volume because none of these scenarios that I'm talking about comply with 8.2.1. They do not comply with 8.2.1. We use 8.3 and 8.4. If 8.3 or 8.4 gives us a number, then that means we have to have a hole in the wall bringing air in from outdoors. So if that's the case, we're done. We're done, 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 done. But if we get a zero, then you have to consider, is that inside of a room or is it just an open building? And if it's inside of a room, then that means we have to allow communication in between the structure and the enclosure, and that's from 8.2.6, A, for all appliances, B, for having draft control devices. Okay, so that's super easy for when we're talking about a structure that does not comply with 8.2.1, when we're talking about appliances that do not have the combustion air brought in from outdoors from the system as a whole. So if it's a direct vent, a 2-pipe high efficiency furnace, any of that, we're not considering it, but anything else, we first refer to 8.3, 8.4, and then if it turns out we get a 0, then from there we can move on to 8.2.6 if it's inside of an enclosure. The next video we're going to talk about if we're talking about structures that have vapor barriers or if they're equivalent to complying with 8.2.1 because they have mechanical exhausts. Okay, thanks very much, and I'll talk to you soon.